So can you starve the tumor cell of their fermentable fuels and kill them? And the answer is absolutely. It's an elegant, beautiful system. And when it's done right, you can't believe how well it works. Problem is, Sanjay, nobody is doing that.
Welcome to Target Cancer Podcast. My name is Dr. Sanjay Juneja. I'm an oncologist known as the OncDoc on social media. And today I'm very excited to have Dr. Thomas Seyfried, who is basically a wizard when it comes to metabolic stuff. And what does that mean? All this stuff that you hear about, like, are there amino acids we can basically starve cancers with? Or what does it do to have a keto diet, and does that help? He's got over 150 publications. He's extremely respected in the metabolic world, and we're just so excited to have you. So thank you for being here, Dr. Seyfried.
Well, thank you very much for having me on your program here.
Of course. So I'm just going to get straight to it. Usually the first question I get on social media, where people really passionate, right, and caring about either themselves with their cancer or especially with a loved one, ask the question, can I starve my cancer? And especially with like limiting sugar and things like that. That is kind of true and kind of not, right?
We always have to go back to energy. Without energy, nothing can survive or grow. So you say to yourself, well, we breathe air, we exhale CO2, we produce CO2 and water from the foods that we eat. You and I are having a conversation. We're talking. Obviously, there's energy going on somewhere in our brains and the rest of our body. And that allows us to do what we do. Now, if you and I were to take a cup of cyanide and we would both drink it together, neither of us would have much energy. We would both fall and collapse right in front of the screens. Let me put it another way. If you and I both had tumors growing in our body, and we were both drinking the cyanide together, and someone would say, whoa, what a catastrophe. These two guys that think they know what they're doing just killed themselves, but they had cancer. So we're going to take the tumor out, and we're going to look at it. And the tumor cells would be fine. The cyanide would not kill the tumor cells. So we say, whoa, what's going on? How is it possible that the cyanide killed these folks, but it didn't kill their tumor? And the answer is the tumor doesn't use oxygen for energy. It uses fermentation for energy. So Warburg did those experiments years ago, giving rats that had tumors cyanide, and the rat died, but not the tumor. And it was clear evidence that the tumors are not using oxygen for their survival. So what are they living on? How are they growing and alive if they're not using oxygen? And it turns out that they use fermentation. So that fermentation is a form of energy that bypasses oxygen. So that's interesting. They're fermenting, huh? Well, what are the fuels that are driving their fermentation metabolism? What are they using? And it's glucose, the sugar glucose, and the amino acid glutamine. And those are the two fermentable fuels that allow cancer cells to grow. So the answer to your question is, yes, cancer cells live, and can you starve them? Okay, so if we know they're fermenting, and we know that they can't live without fermentable fuels, and you know that there are only two fermentable fuels that are keeping them alive, then you target and take those two fermentable fuels away, and they die. So can you starve the tumor cell of their fermentable fuels and kill them? And the answer is absolutely. And then your question is, well, if that's so simple, how come no one's doing it? And the answer is because everybody thinks cancer is a genetic disease. They're not thinking about what's keeping the cells alive. It's not that complicated, right?
So interesting. So when you say, this applies to really any kind of neoplastic tumor, or is it just for some in particular?
I went through all the major cancers. I spent a lot of time in my iScience paper, and I looked at every one of the major cancers. But you have to go back and look at electron microscopy, and you have to look at biochemistry, and you have to ask, what is do the mitochondria number and function and structure look normal or not? And every case, not. Respiratory systems, they're all like deficient and all these kinds of things. So what I just described to you would be common to all the major cancers that we know of.
Is it possible that the fermentation process is something that is physiologically adapted once you've kind of broken a threshold of no longer being able to meet the requirements of proliferation and growth in a classic, traditional, non-neoplastic cancer cell way, as in the stuff that we are used to, blood flow and oxygen, is it something that possibly, is taking place in the environment of injury, which is why they say, okay, now we need to propagate a different mechanism? Or do you think it was something that originated, early on into the pathogenesis? Was that almost a required tool to even permit it to become into something that ends up being neoplastic or cancerous?
Yeah, well, that goes back to the how does this process happen in the first place? What is responsible for the dependency on fermentation? Because as Otto Warburg said, you can never get a cancer cell that cannot transition from respiration to fermentation, and the evidence for that is we rarely, if ever, see neoplastic cells in neurons of the brain. They just simply cannot sustain, they cannot replace oxidative phosphorylation with fermentation. You see it in glial cells, of course, which
Right.
those cells can. We don't see cancers of cardiac muscle, rarely of skeletal muscle, because those kinds of cells cannot, they'll die without oxidative phosphorylation.
Oh, so that observation in and of itself kind of prompts the thing like, well, why is that the case, and supports, exactly what you're saying. What are some of the things that, if you do deprive it of fermentation, would kind of take injury? Obviously, we've just said unlikely the central nervous neurons and cardiac tissue, but is there something that may kind of take an insult that's not cancerous in your body if you deprive those things?
Oh, sure. If you go and try to knock out glucose and glutamine fermentation by itself, you're going to harm the rest of the body. However, what we do with the cancer patients is we transition their whole body over to a ketotic state, ketosis. So all the normal cells of the body, brain cells, liver cells, they all can burn fatty acids or ketone bodies.
Right.
Once the patient is in therapeutic ketosis, then you can lower blood sugars down to very, very extremely low levels. I mean, 0.5 millimole, 9 milligrams per deciliter. I mean, you can push blood sugars down to incredibly low levels. But the brain and the rest of the cells are protected because they can burn fatty acids and ketones. And going back to fermentation, fatty acids and ketone bodies are non-fermentable. They cannot be fermented, so they become non-fuels for the tumor cell. So obviously, the answer to your question is yes, you can damage the body if you just simply target glucose and glutamine without first transitioning the body over to ketones. Once you do that, then the rest of the body is totally protected, and the cancer cells become marginalized and killed off without harming the rest of the body.
And why is it that they can't use, when you go into ketosis, why they are unable to use those? Do we know?
You need a good mitochondria to burn ketones and fatty acids. You need a good oxidative phosphorylation system. And the common phenotype of all major cancers is deficiency of oxidative phosphorylation. So and from the structure in evolutionary biology, structure determines function. That's why when you look at the electron microscope and you see ghost mitochondria, no cristae, dysmorphic mitochondria, you know they're not going to be able to generate energy through oxidative phosphorylation. So you know they're going to have to be dependent on fermentation.
Gotcha.
It's very simple,
Yeah.
not complicated.
We pardon this interruption real quick. If you're enjoying this podcast or find it valuable for what we discussed and the education and how people see and think about cancer in general, we would very much appreciate a like, subscribe, and especially a share so we can bring that information as maximally and broadly as possible. Thank you so much for listening.
So this is just, me thinking out loud, but when we use these things called, for people listening, like VEGF inhibitors or, endothelial vascular, basically growth factors, where tumors are especially the kind of juicier tumors that want blood flow, like renal cell carcinomas and cholangio and liver, like a lot of that, a lot of those, lung even, want to be able to recruit blood vessels. Does that further inhibit the tumor's, ability, and do you use them concurrently at all? Or does that, why does that work in these cancers?
Doesn't work. It doesn't work. That's why they threw out all the anti-angiogenic drugs. Even Napoleon Ferrar, who developed one of these, says that this stuff doesn't work. The cancer cell doesn't need all that stuff. And don't forget, angiogenesis is a downstream effect of damage to oxidative phosphorylation. So when the cell can't respire, HIF-1 alpha, which is a powerful transcription factor, turns on glycolysis and runs vascular endothelial growth factor. So all that stuff is downstream. So you don't have. That's why Avastin and all these crazy things that people are using, they don't work. They don't work because the damn tumor cell doesn't need it. As long as it has in the microenvironment the necessary fuels. Yeah, that's why when you give brain cancer to I told it's like malpractice to treat somebody with Avastin. What it does is it forces the cells out into the neural parenchyma. You can't see them on PET scans or MRI, CAT scan or anything like this. Those damn cells can, and they're also phagocytic. So you got to know that they can eat engulf stuff from the microenvironment, get glucose and glutamine from the microenvironment, even if you try to stop the blood vessels and things like this. None of that stuff works, man. You got to realize. How do you know that? We got over 1,600 people a day dying from cancer. So obviously, all that stuff is not working, and it doesn't work because it's not focused on this essential issue that we're dealing with: fermentation.
I mean, they definitely don't like necessarily cure cancers, but at least for renal cells, I mean, we really have two groups that are seemingly more immune sensitive and more angiogenic, and that's so we use a lot of the TKIs now, in combination or without with immune therapy in that setting. But you're correct. I mean, eventually there's a statute of expiration where it's no longer usually effective. So very interesting. And so that is a way that it's almost like an agnostic treatment, tissue agnostic, in the sense that we've said before, where what I'm hearing is it doesn't matter what the origin or histopathology to some degree is on where it originated, but really it's just a matter of, is it this neoplastic thing that had to really know to exist without being able to use its mitochondria functionally, and therefore wherever it is, wherever it originated, it sounds like you have a high degree of success, I guess, if that's the right term, just by putting yourself into that state.
Well, I think you have to recognize that we can use diets to reduce glucose, but we can't use diets to reduce glutamine. And glutamine is an essential amino acid for the tumor cell. In fact, they call it a non-essential amino acid, but really it's quite essential for our immune system, for our gut health, for the urea cycle. I mean, we need glutamine. And glutamine is abundant. It's the most abundant amino acid in our body. So we have a situation here where our normal cells of the immune system need the same fuel, use the same fuel that the neoplastic tumor cell uses. So we have to. That's why we developed the press pulse strategy for managing cancer. You can press glucose down consistently because you're transitioned over to ketones. So we eliminate the glucose issue, but we use drugs to pulse glutamine. Because if we're too aggressive in targeting glutamine, we compromise our own immune system in its ability to pick up the dead cancer cells after you kill them, otherwise leading to infections and other kinds of adverse effects. So we use small doses of glutamine targeting drugs once the patient is in therapeutic ketosis. So we put them on just for a short time, dosage timing and scheduling, and then we pull them off. And let the immune system and the gut and everything come back to a normalcy. But you've already slaughtered a significant number of tumor cells. And then the immune system, our immune cells aren't killed by the deprivation of glutamine. They're just stunned. Mm-hmm. They're alive, but they're just like paralyzed. But once you pull the glutamine drug back off, our immune system reactivates and goes in and picks up the dead corpses. And we have to have a time period while this process is taking place. And of course, when you add the glutamine back or don't remove the drug, you will get the rescue of some of the tumor cells that might be there. But they're not coming back very fast because you got the chokehold on the glucose. So they're there, but they're growing extremely slowly. And then once our immune system comes back, recovers itself from the small dose of glutamine inhibitor, then we hit them again with another small dose of glutamine inhibitor, and we slowly degrade the tumor while the rest of the cells in the body are generating an excessive efficiency in health. So we're the rest of the cells in the body are getting super healthy while you're slowly degrading the tumor cells that are absolutely dependent on a fermentation metabolism. It's an elegant, beautiful system, and when it's done right, you can't believe how well it works. Problem is, Sanjay, nobody is doing that.
Yeah, I mean, I think the first time I heard about it on a clinical setting was Dr. Siddhartha Mukherjee. I think he's got a new project he's working on for pancreatic cancer. I think more particularly for that, the glutamine metabolic, starvation process. But gosh, that is really like almost like getting goosebumps as a traditional, obviously medical oncologist. You know, it makes sense on a cellular level, and I'm just like, part of me just like wants to believe, well, if it's really fast replicating, like shouldn't we sprinkle a little, cytotoxic chemotherapy just to accelerate the replication process? Or
Well, you can do that. Our colleagues in Turkey do that, Istanbul. They use the lowest possible doses of chemo that's allowable by the profession,
right,
so you're not out of compliance. And once the body is in nutritional ketosis, these chemo drugs also you can use very minimal dosages, and it just slaughters these tumor cells, and you've reduced the level of toxicity. My view is, well, I'm not against that because I've seen spectacular recoveries of some people doing this kind of a strategy. But why would we ever want to put any level of toxic material into our body when we really don't have to?
yeah,
So I'm not opposed to people who say, let me use the lowest doses of chemo once I get my patient into a nutritional state of ketosis. Because the toxicity levels are significantly reduced and the therapeutic benefits are massively high. So this is why when we used our glutamine inhibitor, 6-deoxynorlucine, which was considered too toxic when it was used by itself with not targeting glucose. Oh, it's toxic. But it's never been as toxic as cisplatin, carboplatin, lumistine, and all these horrible drugs. But once you put the patient in ketosis, you can use very small, tiny doses of this stuff, and it's just like a whack, man. You just swack those tumor cells because they're so vulnerable now. They're just like on the precipice of survival, and you hit them with another little bit of a dump, boom, they're
they're
gone.
brittle. Yeah,
So,
wow.
yeah, they're very susceptible. But you got to put the body in the right state before you can use this kind of stuff. You just can't go in there like a bull in a china shop. You really need to know the strategy of what we're talking about. So it's a graded process. Why we developed the press pulse therapeutic strategy for managing cancer. It's a process, and you have to know how to use the tool. The tools that you have are diet and drugs used in the appropriate way. So you can't use glutamine inhibitor by itself. You can't use glucose inhibitor by itself. You can't use the diet by itself most of the time. You have to put the package together and know how all the components fit together so you have powerful synergy without toxicity.
And in what sequence? And that's, I think the Dr. Sid made that clear.
Dosage, timing, and scheduling. This is where we are right now. We're perfecting dosage, timing, and scheduling in our preclinical systems, and then we translate it directly into the patients with my colleagues who have clinics that can do all this.
That's amazing.
So it's a work in progress. We have a very singular goal. How long can we keep stage 4 cancer patients, regardless of what tissue of origin? How long can we keep them alive with a high quality of life? If they die at 98 years old when they had cancer at 38 years old, they were obviously cured with no recurrence.
Right.
But you can't know that. I mean, when you say, "Oh, you can cure," I don't know if I can cure cancer. All I know is if you can live far longer than you were expected to live with a higher quality of life, that's good in itself. And if you live to be 90 because you managed this when you were 30, then you can consider yourself very fortunate. So, but the goal is, how do we keep cancer patients? All these guys, I had stage 4 lung, brain, colon, and they're all out. Many of them are out there doing well. Are they cured? I have no idea, but they're still alive longer than they would have been predicted to be.
That is something else. So I'm sure a lot of people are thinking this, and myself included. Is it conceivably correct if somebody said if they are constantly in a state of ketosis, the likelihood of having a neoplastic or cancerous population of cells spawn in a constantly ketosis state is low?
Yes, absolutely. And how do we know that? We know that from historical records in Aboriginal peoples. And we know that from our closest relative, the chimpanzee, which are the chimps are 98% similar to us in gene and protein
Right.
sequences. And the Aboriginal tribes that existed have been examined at length. The Inuits from the Alaska and Canada regions, the African tribes, the rainforest people, the Australian Aborigines. These folks never had cancer. And they're always in a semi-state of ketosis because their natural diets are very low in carbohydrates. So when you're very low in carbohydrates and you have a significant amount of exercise, you're always in a low state of ketosis. You might have 0.5 millimolar ketones circulating. Your blood glucoses are low, and it's very hard to generate a cancer if you have a very healthy mitochondria. The only way you can get cancer is damage to the oxidative phosphorylation in the mitochondria. So whether that comes from drugs, diets, or whatever, if you're in a state of ketosis, you're enhancing the health and vitality of your mitochondria. So it makes it very rare. That's why Albert Schweitzer, the great humanitarian physician, looked at 40,000 people in the African. He never saw cancer in any of these patients. So he said, wait, no, what's going on? Why these Africans don't get cancer? Why the Inuits never? Now the problem is the Inuits are loaded with cancer, type 2 diabetes, cardiovascular disease. As soon as the Western diet comes in, highly processed carbohydrate foods put you in a state of inflammation. Inflammation damages respiration. So chronic inflammation can damage respiration in a population of cells in some tissue, eliciting cancer. We have an obesity epidemic. In fact, obesity is now replacing smoking as a number one risk factor for cancer. Right? So what's going on with all that? Diet and lifestyle. It's all diet and lifestyle. So you're not exercising. You're eating horrible foods, putting yourself in an obese state, inflammation, and that puts you at risk for all kinds of different cancers.
And you're saying the inflammation, when I always said it kind of, basically invites chances of error, and inflammation obviously decreases your good immune cells to be able to clear an area. You're saying, in addition to that, if not, almost most importantly, it's that inflammation allows an environment for the mitochondrial injury or dysfunction to occur.
Yeah, and then what happens? So you put that's chronic. It's chronic. It doesn't happen overnight. Obviously, right. It takes sometimes years for that constant inflammatory insult, whether it's intermittent hypoxia, chronic inflammation, all these, and then you combine that with some low dose of carcinogens that might be in your body, and you put all that together, and then gradually oxidative phosphorylation is replaced by fermentation during that process. And when the oxphos becomes dysfunctional, it throws out reactive oxygen species, ROS. ROS are carcinogenic and mutagenic. So the mutations that you see in the nucleus, all those somatic mutations, are all downstream effects of the ROS produced by the damaged, chronically injured mitochondria. So the cancer field, for the most part, are chasing the tail. They're chasing effects. They're not focusing on the real issue. So you're looking at how many different kinds of somatic mutations people have in their different cancers, which is largely irrelevant. All that stuff is largely irrelevant. The National Cancer Institute says cancer is a genetic disease, and nothing could be further from the truth. I mean, it's not a genetic, it's a metabolic disease. So why is everybody focusing on all these crazy mutations when they're all downstream effects? You don't get the mutations until the mitochondria become dysfunctional. So you put carcinogen, you can see the mitochondria become damaged. They bioluminesce, actually, and you can see them throwing out ROS already. So it's a staged chronic process. It's very hard for the human body to get cancer. You can't believe how tough it is to get. We evolved to be completely resistant to cancer. So in order for us to get cancer, you have to have a long-term self-abuse of your body by exposure to all these kinds of things, because the Aboriginal tribes and the chimpanzees tell us how hard it is to get cancer. It's just
it's hard.
We're just so deviated from our stuff. It's just like, wow.
It's so interesting. Like, hearing you say that is interesting in the sense that I always say, when people ask, frequently, what can I do to reduce my chance of cancer and what causes cancer? And I basically spit a rally off a line of things, and I'm like, basically the same stuff that they recommend to do for cardiovascular health and to not do for cardiovascular health. They pretty much overlap entirely. So am I hearing that possibly because of what's called, what we say vasculopathy, or basically inflamed arterial disease, if you smoke, if you have diabetes, glycosylation, all the stuff that makes maybe impaired vascular flow, is that in some way a superimposition of why people get cancer as well, because the delivery of oxygen and then the increase of ROS are the things that are propagating or inviting cancers, right? Is that a fair
Yes,
statement? That's crazy.
I think it's very fair. It's a very fair
And so
statement.
that is why there's such an overlap, is because of the mitochondrial injury that occurs due to impaired, blood flow because of, again, diabetes, smoking, lack of cardiovascular health.
Yeah.
So what, when you said, processed foods, obviously I spit that off on the list as well as one of the reasons that can cause cancer. But say somebody was keto, but ate processed foods. Like, what is it about the processed part itself that invites the mitochondrial injury? Which you're saying is you're saying it is an absolute necessity, correct, to turn into a neoplastic cancerous malignant cell. Like, you have to have that. That is like the limiting reagent. Okay, so
Yeah, that's the origin. That's the origin of cancer.
right, and so
It's damage, chronic damage to oxidative phosphorylation is the origin of cancer, which can happen by any number of provocative agents. But when you say highly processed, what is highly processed? So the issue, of course, is that these are foods that are high in glucose, high in sugar, and they have no nutritional value. They're with minimal nutritional value, but high in sugar. Now, don't forget, we evolved as a starved species. I mean, our whole existence on the planet has been trying to survive famine, trying to, we move around. We had to bring tools with us to get the food that we needed. Our physiology and our genome is ultimately driven to store energy. So, because we were always starving. Now we put ourselves within the last, 50, 75, 100 years into a state of massive amounts of carbohydrates that have no nutritional value. And that again causes your inflammation, your obesity, your type 2 diabetes, your cardiovascular disease. So you're absolutely right, Sanjay. This is all part of a continuum. And when in our metabolic approach to cancer management and the folks that are following our instructions, many of these folks come in with cardiovascular disease, type 2 diabetes, hypertension, and all these other kinds of things. And by the way, that all goes away along with their cancer. So, you're talking about a very dangerous situation here. I mean, you're talking, and a point in fact was the recent paper that came out on the Mediterranean diet, reducing cancer, dementia, and cardiovascular disease. And it's not the Mediterranean diet. It's the absence of highly processed carbohydrate foods, which are not part of the Mediterranean diet.
right, and all of
Not,
those.
not complicated, not
So
complicated.
it's not the olive oils and all that stuff as much.
No,
Yeah.
it's the absence of the highly processed carbohydrates. You want to neutralize a Mediterranean diet, go out and eat a big Subway sandwich or eat a couple of Dunkin' Donuts, and you can neutralize all the
Right.
therapeutic benefits of a Mediterranean diet real quick.
That's too funny. And it's so true because again, it's just why is it a coincidence that it's always the stuff that helps, reduce chances of heart attacks and strokes, and they have good cardiovascular health. Oh, and also they have like less cancer. Like I love that we're actually really kind of somewhat pegging, bro, it's not just a coincidence. Like there's a reason those things almost always,
Yeah.
align or superimpose.
I tell you, nobody really cares. I mean, unless it's really pointed out like I just did. And I tell you why nobody cares? Because we have an obesity epidemic. If people really cared about preventing cancer, we would not have an obesity epidemic.
Yeah, yeah. That's hard. What I think is just those things are so distant, like the concerns, which hopefully things like this and hearing this, I mean, I'm more motivated right now to be healthier and eat less processed foods, than I've been probably in a long time. Like just hearing all this, because now when you
Yeah.
understand and hear it, you're just like, I feel like, again, that's why we're doing this, is that it makes you now empowered. Instead of hearing like, oh, your risk will be higher, it's like, this is what's happening. This is where you have the potential for mitochondrial damage. This is why. This is your arteries getting all like clogged up from X, Y, and Z, and then all these sugars or whatever. Now it's like, now I'm doubting my lunch now.
Yeah. Well, but the problem is, of course, we have fast food stores on almost every corner in every place in the United States. It's so convenient. And not only that, we're saying, wow, geez, do you ever eat this stuff? Do you ever eat a Subway sandwich? It's absolutely delicious.
Yeah, it's
You ever have
amazing.
McDonald's hamburgers? This stuff is like so good. Taco Bell, are you kidding me? Papa John's pizza. I mean, these things are really, really tasty. I mean, they've been designed to make you want to eat this stuff. they should put a skull and crossbones on a lot of that stuff just to let you know every now and then you shouldn't. Just like if you do it all the time. I'm not saying we should purge our society of this stuff because I enjoy it myself too occasionally. But the problem is I think so many folks in our society are just like, they don't know that if you do that, if you're eating poorly processed, and it's not only that, it's our lifestyle. We're not as active as we were. Those Aboriginal tribes that I spoke about, those guys are out working in the fields. They're doing stuff all the time. They're not sitting in traffic listening to books on tape or sitting in front of a computer, chowing down a big blueberry muffin. It's like it's a combination of the foods that we eat, the lack of exercise, the mental and emotional stress that we have in the society. All of these things impact together to damage the mitochondria in some population of cells, in some tissue, putting you at risk for either diabetes, cancer, dementia. Let's go on the dementia thing. It's all part of the same process.
Yeah.
And we're paying the price. We're paying the price for tasty foods and convenience.
Yeah.
And that people need to know.
And
that.
I mean, it's almost like it's not our fault because we were made to to have a penchant for those things because we needed to know when we were absent-brained and stumbled across some whatever on the field, like we needed to know that this was a high calorie thing so that we wanted more of it. So it's like a bottleneck effect over evolution that's now that's why they say with intelligence and greatness comes demise potentially, or concern for such. We're still stuck with the things that we needed when we were very ambulatory and desperate, but the availability is abundant. I like what you said about tying in really the concept of like having to move around and be like more physically active. It's not so much that we're saying like, oh, be active to lose weight. We're saying that it's that activity that really, burns things and burns fuels and makes you. I love that angle on explanation on saying like, don't just do it to lose weight or be healthy. It's the actual process. And one thing that I remember reading when I used to, be kind of a workout junkie kind of person was that the best kind of cardiovascular health you could have and decrease your chance of heart attack and stroke is even less than 60 to 80 minutes of cardio in a day is doing 10 minutes every hour or every other hour of getting your heart rate up. And that goes into that concept of constant, like, burning it up and making you have to break into some of these like, chains and stuff to that is the thing that protects your body, as ideally as regularly as possible.
Absolutely. You're making your mitochondria healthy. You're giving them the oxygen they need. You're increasing the blood flow. You're just generally making yourself healthier. I agree with you 100%. I don't think it's just to lose weight. I think it's just to keep healthy.
Yeah.
Walking, swimming, whatever you're capable of doing.
Make your body need to make energy, like at a moment, like make it dynamic, make it,
We are a very mobile species. We would cover great distances looking for food. It's in the Paleolithic period of our existence before the cultivation of grains and the development of civilizations. I mean, think about how hard it was to get something to eat. I mean, you had to track down some animal that was oftentimes bigger than you with team effort and drag its ass back and chop it up and eat it. And there's a lot of energy that goes into this.
Can
right?
you imagine and then, the reward?
And you're going to, and then you're going to gather a few ripe berries when they're in season, and you're going to gorge yourself on those things, but that was and we survived. We actually survived in these products because we learned how to use certain tools. We learned how to kill animals in a better way. Now we can farm them, where they put them out on a pasture and stuff like this. I mean, but we survived because we have. Rick Potts of the Smithsonian put it pretty clearly. We have this capability of adjusting to the environment better than most other animal species have, and our genome and our physiology is all geared into survival under extreme conditions. And now we put ourselves in a new environment, completely different from the environment we evolved in. And we have all of these different kinds of chronic diseases, cancer included. So it's not that mysterious when you put everything into the concept of biological evolution.
No.
And that becomes very clear what the situation is. And then we spend billions of dollars trying to put a Band-Aid on type 2 diabetes, try to put a Band-Aid on cardiovascular disease and cancer and all these kinds of things, when we just have to keep our mitochondria healthy and we won't have to deal with these issues in the first place.
Yeah, I mean, that was very beautifully said. It makes sense on just a macroscopic logic level. The more you like get distant from the very cellular and behavioral, adaptations we've made to exist as a human race over hundreds and thousands of years, what the things we had to get selected for, the things that died off if they couldn't store their fats well enough or didn't have the taste for fats and said, "Oh, I don't like fats." Well, you're dead, because that's the thing that's going to make you like the most likely to live. So, the fact that we had all of this, it's almost irreverent. And then to say, let's go ahead and now live a life that is very divergent or like distant from exactly what this that's the sharpest blade that you sharpen.
Yeah, no, you're absolutely right. And now you don't even have to unask the car. You can just drive up and they hand you the food right through the window.
Yeah.
You don't even have to get out of the car, right? I mean, rather than walking in to get a donut or something, oh no, I got to drive around and wait in this car line. And then some guy, a hand comes out of the window and puts a load of food into your lap.
Thomas, I want it in my mouth. I don't want to take the wrapper off. Take it off and put it in my mouth.
And then they wonder why we have obesity and cancer.
Right.
I mean, what the hell's going on here?
But again, one, the flip side, the defender could say it's like we're the tragic hero or the anti-hero, because it's like we're also at the mercy of our own adaptations. I know you're kind of that's called being an adult or being mature and not being a mammal. But we are having to fight the very thing that we are hardwired over time. So, okay, I have one question though that I had heard when it relates to ketosis, and it blew my mind. And talking about shortcuts, right, in society, and as we are, especially in this country, I hear that there are ways that you could consume things and temporarily, so it won't give you a sustained ketosis, but like maybe a 4 to 6 hour ketosis. Or is there such a product that if I took Q6 hours, that I could have a ketosis without having to do the upfront legwork? Because like I said, I want the burger in my mouth, like basically. Is there a way I could achieve that without the 2.5 days of supposedly a headache before I get ketosis?
Well, listen, no. The issue, of course, is we would talk. I worked in the epilepsy field for years, and everybody's talking about can we get a ketogenic diet or ketosis in a pill?
Yeah.
Yeah. I mean, that was the big thing, right? So you really want that? Okay, you take one pill for breakfast, wash it down with water. One pill for lunch, wash it down with water.
You do that for 3 days.
One pill for dinner. Yeah, and you do that for a week.
That's hilarious. That is the holy grail of a marketing scheme, because it's true and you're not doing anything.
But more seriously, when you say, "Can I get into?" It's the sustained condition of being in some level of moderate ketosis that's really the most healthy for your body. And, we're learning now from a lot of folks that are measuring we developed here at Boston College the glucose ketone index, which was for the cancer patient to know when their blood sugar was low and their blood ketones were elevated, and they then become at the perfect condition for low dose chemo or targeting glucose and glutamine. We built that, but now we realize that you can stay into those zones with a carnivore, consuming of carnivore, with Mediterranean diets, with vegetarian diets, as long as you don't eat too much and the foods that you eat are very low glycemic. You can get into these states of ketosis with not too much difficulty. The only difficulty would be the restriction of highly processed carbohydrates. And for some people who happen to be addicted to those kinds of things, because glucose is a powerful addictive fuel. It's like cocaine, it's like opium, it's like nicotine. It can be very powerful on the brain. But we evolved not to have very much glucose in our diets. So we will fall back. Our bodies will recognize that we are back in a semi-Paleolithic state. But we can get into these zones of ketosis. So my colleague Dominic D'Agostino from University of South Florida, and he's made ketone ester solutions where you can take that and just like you said.
Right.
But it goes away. It goes away. You really want to get it to be sustained, and sustained ketosis with low glucose is very, very therapeutic. And people can do this. I mean, at first we were saying, oh, you got to do water only fasting. Well, that doesn't go over real well. Nobody, after a couple of days, you're out of that.
Yeah.
You say, the hell, I'm gone from this. But, with a carnivore diet with certain kinds of low glycemic vegetables and things, you can get into these, and you use the GKI to know whether you're there or not. So we did it for the cancer patients, but now we see all these young healthy folks, not cancerous, not cardiovascular, none of these chronic diseases. They're all doing the GKI because they know that if they're in this zone, their mitochondria are going to be at the healthiest state. So they're using it as a prevention, as a health benefit for their body.
I want to use it.
But yeah, GKI, glucose ketone index.
On it.
You get it from the Keto Mojo. And when we made it, we had to ask people, because you get blood sugar in milligram per deciliter, and you get ketones in millimolar. So you have to divide the glucose by 18 and then divide that number by the millimolar of ketone. It is too much. So the Keto Mojo guys made a little chip in the meter. So all you have to do is get the blood value and you do the glucose strip and then the ketone strip, and you push the button on the meter. And it gives you voila, you get the GKI right there. You don't even have to do the arithmetic anymore.
Dr. Seyfried, you were amazing. I would love to have you back. This has been so edifying, and now I almost have anxiety that I've been slacking for 35 years. So, you definitely have catalyzed my thinking on this, especially with young kids, and I'm excited to do some digging. But we appreciate you, so where can people find you if they want to read more on your material?
We've published our papers in peer-reviewed journals. Curis is one of them, for our case reports. But anybody can look my name up and see the publications that we've written on PubMed, publication of
Excellent.
Library of Medicine.
All right. Thank you so much.